And welcome back, students. We're going to continue talking about packages in Java. We're going to discuss the rest of packages. Today, we're specifically talking about the package names and their directories. So the first thing to discuss is something known as the class path variable. Now, if you recall, we attempted to add a package in our previous lesson. Opened up Eclipse, I made a couple demos just to kind of show you how to make a package. Now, a package name is not an arbitrary identifier. Instead, it is a form of path name to the directory contained in the classes within that package. So in order to find the directory of a package, Java needs two things. It needs the name of the package, which is pretty self-explanatory, and the value of class path variable. And when we start talking about class path variable, that would be when you're actually if you actually look at your C drive, for example, and you have it stored there, or your N drive, or wherever it's stored, what is the file path? Class path is another name. It's what's the file path for that package. Now, you should all be familiar with the environment variable of your operating system that's known as the path variable, which I just kind of mentioned. Path is just where it's at. So the class path is then it's a similar one, which helps Java then locate the package. Now, the value of class path variable tells Java where to begin search for a package. Now, when I say class path variable, an important thing to note is that it's not a Java variable. It's not something limited to Java. Rather, it's an environment variable that is part of your operating system, which means this is what your operating system is using to tell where different things are located. Now, the value of your class path variable is a list of the directories. So like I said, it's pretty much, if you're using Windows environment, it's going to be your file path. Now, where is this thing located? Wherever. Now, the exact syntax for the list varies from one operating system to another. So how you do it in Windows is going to be different than how you do it in Mac. And how you do it in Linux and all these other operating systems. It varies. But it should be roughly the same kind of syntax as used for an ordinary path variable. So, it's the same kind of thing. So if I have my file path for finding a file, it's going to be the same kind of file pathing method for finding the class path variable. Now, when Java is looking for a package, it begins searching the directories listed in the class path variable. So again, class path variable says, hey, start looking here. Now the name of a package specifies the relative path name for a directory that contains the package classes. It's a relative path name because it assumes that you start in one of the directories listed in your class path variable. So for example, suppose the following is directory listed in your class path variable, /library/new libraries. And suppose your package directories are in the directories libraries/new libraries/utilities/numeric stuff. In this case, the package should be named utilities.numeric stuff, and all the classes in the file must start with the package statement package utilities.numeric stuff. Makes sense because remember, the class path variable points up to new libraries. So it's going to look in that new libraries directory, that folder, if you will, for different things. And so since our package files are in utilities, we just point it to the folder utilities, and then we point that to the folder numeric stuff. So if I want to use a class that's in numeric stuff, I have to do utilities.numeric stuff dot whatever the class name is. All right, that dot that I just mentioned essentially is the same thing as a slash used by the operating system for directory paths. So really kind of think about when we start thinking even about things such as our import statements. If we say something like, import java.util.scanner. So it's saying in the Java libraries, there's a slash folder for utilities, and then there's a slash in there inside utilities. There would be a file called scanner. So it's the same kind of principle here with packages. Now the package name tells you, and also directly Java, what subdirectories it needs to go through in order to find the package classes, starting from a directory on the class path. If there happens to be two directories in the class path variable that can be used, then all of the ones that can be used, Java will always use the first one listed in the class path variable. Any class that uses the class in utilities.numeric stuff package must either contain the import statement, import utilities.numeric stuff.star, or an import statement for each class in the package that is used. So once you put the package in, you have to then use that import statement. It's largely what this is stating here. Now, the way you set the value of your class path variable depends upon your operating system. But we can give you suggestions for things that work, all right? Because it varies operating system. Most of us are using Windows, so we're going to kind of follow the Windows path. Now, the class path variable is usually spelled out as one word in all uppercase letters, such as class path. You'll probably find that it's a plain old path variable that tells the operating system where to find the code for commands such as Java, C, and other commands and give a single line. So if you can find out how to set the path variable, you should be able to set how to do the class variable in pretty much the same way. So since we're using a Windows machine, most of us are, you can set the class variable by setting or creating an environment variable called class path in the control panel. We're not really going to worry about this too much because we're mostly, for our purposes, going to be using the default package. So we're not really going to run in this too much. All right. Now, the one thing to note in this course, we do assume that class directories are separated by a semicolon. So when you're going from one directory to the next directory, not saying the file path itself, but if you were to list off multiple directories, our assumption is that we're going to put a semicolon between them. Now, this is common, of course, but some operating systems use other separators such as commas. So if you're not sure, always check the documentation for the OS to find out what they're using as a separator. So here's a quick diagram showing a package name, and this would be something kind of familiar, like if we're working with Eclipse, we can see stuff like this happen as well. So in the diagram, you can see how the different classes are nested into different subdirectories or directories. So for example, earlier we had talked about, here's our programs folder, and here we have our new libraries, and inside of new libraries, you can see we have our subfolder utilities, and inside of utilities, there's the two-folder string stuff and numeric stuff. And since we're going to use numeric stuff, we want to use that one. It has two classes called a class and another class. So library/new libraries is on the class path. That is where we're pointing the class path variable to. Then utilities.numeric stuff is the package name. So I would write, package utilities.newNumeric stuff. Then I could use these two classes right here. I could say import, those classes then. So again, as I mentioned, both a class and another class are in the numeric stuff directory. So this is ultimately what we're looking at right now. All right, a quick pitfall to know, and some of this may not directly apply to us because again, we are going to be using just like the default package for a lot of what we're doing. We're using Eclipse, which handles a lot of this automatically, so we don't have to manually point this. If you were coding things out by hand, if you weren't using an integrated development environment, that would be something that you're really going to have to watch out for. But again, because we're using IDE, it really helps lessen this example of a pitfall, but it's still important to note in case you ever come across it. And that pitfall here is that subdirectories are not automatically imported, right? Which, of course, like I said, this is something to be knowing about. All right, so let's just suppose we have two packages, utilities.numeric stuff and utilities.numeric stuff.statistical. In this case, you can notice that utilities.numeric stuff.statistical is a subdirectory or a subfolder of the directory containing utilities.numeric stuff. In other words, if I open up the numeric stuff folder, there's another folder and other files in there, and that folder would be the .statistical. Now, some programmers falsely assume that if I want to import statements and I want to import both packages, both the numeric stuff and the numeric stuff statistical, I could just do utilities.numeric stuff.star. When you import an entire package, the key thing to note is that it does not import subdirectory packages. So if I wanted that statistical folder, I'm going to actually need two import statements. I'm going to import .utilities.numeric stuff.star and utilities.numeric stuff.statistical.star. You might be wondering, why is that? Well, this is just one of the ways that Java handles packages when it gets imported. It only looks for files. It doesn't look for folders. So if you want anything that's nested within inside of itself, you're going to need that folder. And this can have some really good use if there's like a subfolder within. You might be wondering, why would I want a subfolder? Well, sometimes you don't want they don't need access to every single class, they might only need that specific subfolder of classes. And so that's why you would put a subfolder in there. All right, the default package, which, like I said, we've been using, so we're a little familiar with this. All the classes in our current directory that do not belong to any other package belong to an unnamed package known as the default package. As long as the current directory is on our class path, all the classes in the default package are automatically available to our code. This is why we always assume the classes we define are the same directory. That way, we need not clutter our discussion with concern about import statements. Right? It keeps it simple for our learning purposes. Now, like I said, as mentioned previously, we've been working with, and we're probably going to continue to use, for our purposes, the default package. Now, again, here's another pitfall, one that you should know about, but don't necessarily have to be as concerned because Eclipse handles a lot of stuff for us, is not including the current directory in our class path. Your class path variable allows you to list more than one directory. Most operating systems will use a dot to indicate the current directory. We're in a Windows environment, and so that's what we're using in Java is a dot. The current directory is not any one specific directory, rather it's the directory in which you are currently quote-unquote located. Now, if you do not know what your current directory is, in other words, where is that file or folder of your Java and class files actually on your hard drive at, then it's probably the directory that contains the class. Right? If you're not sure, just where did you save your stuff? Simple. So if it's on a folder on the hard drive, great. If it's a folder on your network drive, great. Now, for example, the following value for a class path variable lists two ordinary directories and the current directory. So I have library/new libraries, and then I have another one separated by semicolon here, other stuff /special Java. So there's two directories right there, and also the current directory. Now, whenever you set or change your class path variable, an important thing to note is to be sure to include the current directory as one of the alternatives, because it's always good to have those alternatives just in case. With the above displayed class path value, the one that we just had on the previous slide, if the package is not found by starting in either one of the previous two directories, Java is going to then look in the subdirectory of its current directory. If you want Java to check the current directory for the other directories in the class path variable, list the current directory, the dot, first as follows. Dot, semicolon, library/new libraries, other stuff, /special Java. Pretty simple. When looking for a package, Java tries the directories in the class path in order and uses the first one that works. So if you want to be the current directory, you put the current directory. If you want it to be the new libraries directory, you just put that. Whatever order you want Java to check things is the order of which you put them. Now, a quick pitfall, like I said, is not including that current directory in your class path, because omitting the current directory from the class path can interfere with running Java programs, regardless of whether or not the programs use packages. If the current directory is omitted, then Java may not even be able to find the .class file for the program itself, so you might not be able to even run any programs at all. Thus, if you do set the class path variable, it's critical that you include the current directory in the class path. Now, no such problems will occur if you have not set the class path variable at all. It only arises if you decide to set the class path variable. If you're having problems setting the class path variable, one internal solution is to delete the class path variable completely and to keep all the class files for one program in the same directory. Now, this will allow you to still do some work while you seek advice on the class path variable. All right. Now, specifying class when we compile, again, this is a lot of stuff that we're not really going to be concerned about because, again, Eclipse is handling a lot of this for us because we're not manually writing classes. We're putting everything in the same folder. But, again, it's good to know. You can specify a class path when you compile a class. So to do so, we can add a class path such as the following. So here's just a quick illustrated example. Java C dash class path dot semicolon C colon / lib / numeric semicolon C colon / other stuff your class.java. When you run the class compile just as shown, you should again use the class path option as follows, and you'll notice it's pretty much the same thing, except there's no .java there. All right. Now, the reason why I went through that is because of the following reason here. It's important to include the current directory on the class path when you run the program. If your program is in the default package, it will not be found unless you include the current directory. So this is one thing to note if you're doing the default. Right? It's best to kind of get in the habit of always including the current directory in all class paths. Because the class path specified is compiling run your class's input to a program, either Java C or Java, that is part of the Java environment and is not a command to the operating system, you can either use the / or / in the class path, no matter which one the operating system uses. Right? Again, this is something that might seem a little confusing, a little bit kind of like when I'm going to use this, but it's just kind of food for thought to kind of help you understand how Java does some of the stuff that it's doing behind the scenes. All right, one thing to note though is name clashes, and this is something you might want to know regardless of if you're using Eclipse or if you're trying to just code everything out foolishly by hand. I always recommend using an IDE. It makes life so much simpler. So in addition to being a way to organize libraries, packages also provide a way to deal with what is known as name clashes. A name class is a situation in which two classes have the same name. All right, so let's say you have two different programs writing different packages at the same time, but they're using the same name for a class. Right? And it ended up being used by another programmer. So there might be some ambiguity into which class you want to use. Well, that ambiguity can be resolved using a package name. So suppose we have a package name, Sally's Pack, which has a class called High Class, another package called Joe's Pack, which also contains a class named High Class. You could technically use both classes named High Class in the same program by using more complete names, such as Sally's Pack.High Class and Joe's Pack.High Class. So if we actually look at that in our code, we have Sally's Pack.High Class object 1 equals new Sally's Pack.High Class, and Joe's Pack.High Class object 2 equals new Joe's Pack.High Class. Those names that include the pack names, such as Sally's Pack.High Class and Joe's Pack.High Class, are what are called fully qualified class names. If you use fully qualified class names, you actually do not need to import the class, since this longer class name technically includes the package name. So rather than saying, import, Sally's Pack or import Joe's Pack, I could just do it this way. So you still have to include the package, but this is getting around having to do an import statement. All right, well, that's going to kind of wrap up our notes for today, folks. And I think we're going to leave right here. The last thing to talk about in this section is the Java docs. So until then.